Hey everybody, let me just walk you through what to include for the Pendulum lab report. So just start off with the introduction, where you can just say the purpose of this lab is primarily to show how the different parameters of a pendulum affects its period. So just how the parameters affect the period. Like the mass, the angle, and the length of the string. And another is to actually measure the acceleration of gravity. So two things, this and 1 and 2, measure the acceleration of gravity. Okay, and then, so this is the first section, and then you can put in a hypothesis where you say, I think neither, well, let's say the mass will not affect the period, the angle will not, assuming they're small angles, but the length will. Okay, and then next is your methods sections, and then you just explain just in enough detail that someone else could read your report and replicate your experiment. Okay, and then your results. This will be the biggest section in this particular lab report, because you're going to have some, let's start with changing the masses. So you have a table where you have mass in whatever units, and then period, and then whatever you used. Oh, that's too much. Let's see. Right, and then etc. Well, even less than that, I think, right? Like this. Okay, and then whatever values you got, and then show the plot. So this is period as a function of mass. So if you had, right, your different values, and then this table should actually have multiple trials, right? So the table's a little bit bigger. This period, and then you had trial 1, trial 2, etc., right? And then the mean of these trials, and that's what you're plotting over here. Each of these is a mean of your different trials, and then you do a trend line, and then you show the slope of the trend line. I'm just making up numbers. Whatever it is. And then you say, right? Then you can say the slope is close to 0. Right, so that you're saying it's horizontal, which means the period is independent of the mass. Right, and then you do the same for the angle, and you have different trials, and then the mean is for your different angles, then the mean values of those angles, and then you draw a plot. Period as a function of that angle, and then you show, right, these are the mean values of your different trials. Same, you do a trend line and show the slope of the trend line, and you say, okay, the slope is close to 0, which means the period is independent of the angle, assuming small angles. Right, and then the third variable you adjusted was the length of the string. So here you have length, and the period for your different trials. Right, and then here's the mean of these trials. Here, 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 here. Okay, now when you do this graph, it should look something more like this. It's not going to be horizontal for one, nor is it going to be linear. It's going to be some kind of curve. So you just want to see that curve, and then we want to linearize that. So you can just add another column to this. So this is going to be period squared, right? So you just take the mean, right, of your trials. This is period over here. So you just, what goes here is just the square of this. So you're squaring it, and then you do a fourth graph, right? 1, 2, 3, a fourth graph, which is period squared versus length, period squared versus length. This is period versus length. And that should look more like this. It should be linear. It should be, because we're assuming that period is like this. And then when you do a trend line here, right, then you get the equation for the trend line. This is the slope. Okay, and then you put this in your lab report too, this equation, this assumption. If you square this, what do you get? 4 pi squared L over G. Okay, and then let me move the L over here. Okay, right, so then if you look at the equation for the trend line and this equation we just derived here, right, this is like y equals, let me just write over here. Y equals mx plus b. So if there's no y-intercept, just ignore this. We're just looking at comparing these right here. Right, so then 4 pi squared over g equals that slope. This, again, that's the slope of your trend line. So just trade these two. So g is 4 pi squared over that slope. So this is a way to compute, to measure the acceleration of gravity. Right, so then just get this number, whatever you get, whatever this number is, I'll just make up a number. There you go, right? So whatever this number is, you can compare this to what you expect. And then you say, okay, it's pretty close. Or whatever you get, it's fine. Just report it. Okay, and then just wrap up your lab report. There's some analysis section. You can just talk about whatever sources of error, and you can report on this difference right here. You can just say it's like however many % different. And then conclusion, you can restate your hypothesis. And then just say the other things we said earlier, where the period is independent of the mass and the angle, but then it depends on the length, right? That's what I'm expecting you'll find, but you just report on what you actually find. Say period depends on the length, but not linearly. Meaning, right, this wasn't a straight line. and then you measured G, and then you, whatever your answer was, whatever number you got, you just reported over here, which is however many % error. And you're good. Okay? So that will wrap up this lab report. So let me know if you have any questions, and then just post to the forum. Okay, take care. I'll see you.